Hi everyone. Today we are going to see about the why the steel is used in concrete. Before entering into the topic, we need to know what are all the disadvantages in concretes. So in concrete, the concrete is strong in compression and weak in tension, and the tensile strength of concrete is 0.7 root of FCK as per IS 456 2000. So we can say the tensile strength of the concrete is 10% of compressive strength only. So the concrete will not take the tensile loads in a structure, and brittle in nature. So concrete can easily brittle if the reinforcement not provided in the member. These are all the disadvantage of concrete. We need to overcome the weakness of concrete. Then only we can make the durable structure. In steel, the steel will be strong in tension. The steel is strong in tension and ductile in nature. In our buildings, this is the most probable property of the structure. So if our building in brittle in nature, it won't give any alarm to fails. But if we are using in a steel in a structure, it will giving the alarm like small cracks in the structures, like small bends in the structures. So these are all the symptoms the steel can give, but the concrete won't because it's brittle in nature. The ductileness refers to ability of a material to sustain significant plastic deformation before fracture, and the steel will take the flexural moments. If in beams and slabs, what are all the flexural moments happening into the structure, the steel can take all the moments without any failures. In RCC, mostly we are used steel as a reinforcement in a concrete structure. What is the reason behind the steel usage? We have seen some of the most important properties of concrete and steel, but as a RCC, one major property is there, that is coefficient of thermal expansion. If we are making RCC structure, the concrete and the steel need to be expand and contract in a same way. So property of thermal expansion, the coefficient of thermal expansion of concrete and the steel is probably same. So the coefficient of thermal expansion refers to the rate at which a material expands with increase in temperature. If we keep in any one material, it will expand with respect to the temperature. We can refer IS 3414 1968. In this code book, table number 1, the coefficient of thermal expansion of various building materials within range of 1 degrees to 100 degrees Celsius. The thermal expansion values are taken at the time of temperature like 1 degree Celsius to 100 degrees Celsius. The coefficient of thermal expansion value of cement mortar and concrete is 10 to 14 into 10 power minus 6 per degree Celsius, and the coefficient of thermal expansion value for steel and iron 7 to 13 into 10 power minus 6 per degree Celsius. So we can see the coefficient of thermal expansion value for cement and steel here. The concrete and the steel value is probably same as per the IS 30414. The compatibility between the concrete and steel is much more better than the other metals. So this is the reason we are using steel in RCC structure. I think the information is useful for your learnings. Thank you.